Hello again. Continuing with our project, we will start doing the last steps of getting the final printed circuit board ready as a final product. The thing that we need to do today is to fabricate using milling machine and also to solder. Before to start dealing with the milling machine, which means milling and drilling, and before of soldering, we need first to generate the Gerber and the drilling files. The same steps we did at the end of lab number 5. Okay, so let's open again our project. I will share the software with you. So this is our last board which we have last time. This is our last board. Just to remind you what we did, we connected the components footprints over this board here. So here we connected the positive of the source to input of the regulator, then the negative of the regulator is connected to the negative of the source, output of regulator to as it will be as an input to the sensor. Also we connected the second pin of the sensor to the second pin of LM741, pin number 3 to the resistors, pin number 4 to the ground, pin number 7 it's connected to the positive, pin number 6 it was an output of our circuit, pin number 3 of the sensor it was connected to the negative, and pin number 4 of the sensor it was not connected. So the thing that we need to do now is to create first the outline, then to generate the Gerber files, the drilling files, and then I will show you two videos, one for milling and drilling, and the other one it will be for the basic techniques used in soldering. Okay, so the first step, we need to go here to outline. We need to design 2mm outline in order to make sure that the drilling head and the milling head is working inside the board. So we'll press on design. We need it to be 2mm, so we'll change this 4 to be 2mm, and then we'll start drawing here from the corner to the corner. Once you finished, just press close. So now we have this 2mm. As we can see now, once I have this 2mm, this trace is out of this 2mm. So I will try to bring it inside the board, not to have anything outside this 2mm. Sometimes when you are trying to move the components, you have to make sure that the connection stayed in its places, otherwise just delete the trace and replot it again. So I need to move this wiring here. Let me check if I can do it. Okay, then I will move this one here. Okay, that means I need to move this a little up, and this one also a little up. Okay, I will delete the traces from here, and this trace also. This is because we don't want any trace to be outside of our outline, so we will move them up. Okay, so this was connected here, and from here we need to connect it here. Okay, then this was connected to the positive, and this was connected to the negative part. So now I will try to move this trace up. It's moved, and this one also from here. At any point, if we have if this point is not connected, then we have to delete the trace and to add it again. So I will delete this one, I will delete this one. Okay, so it's now connected, and we need to connect pin number 4 to the negative, and that's it. By this we have all of our traces inside the outline. Just save your work. Okay, so by this we are just making sure that everything will be inside our outline, which is our safe area. Then after that we need to start generating the Gerber files. So we will go to export, and then we'll click on Gerber parameters. From here we have the bottom and top, and we need to add another layer, which is the outline, the one we just created here. So click here, right click, and add manual. We need to name it outline, then press OK. Then we will search for board geometry. We have it here, and then we'll click on outline and OK. So we have now bottom, top, and outline. We need to make sure that the line width 1 millimeter for bottom, 1 millimeter for outline it's 1, and for top it should be also 1 millimeter. Then we will go to apertures. We'll press on edit, auto without rotation, and then OK. I'm just reminding you about the steps we did at the end of lab number 5. It's the same steps. So select all, and then we will create the Gerber files or create artworks. It will start creating the Gerber files. Once you get this document here, or this report, that means you finished creating the Gerber files for the bottom outline and for the top. Now we need to save our work, and we need to create the drill files. To create the drill files, again we'll go to export, and now we will go to NC drill. From here we have to choose auto tool select, then we'll go to NC parameters. We need to click on leading 0 suppression, and also you can click on enhanced format, then close, and now we will create the drill file. That's it. Once we finished, we can press on close. So now we are ready. Just save your work. We are ready to take those Gerber files, top, bottom, outline, and the drill file, those 4 files. You can check them using the gerberviewer.com, and then later you can take them to the milling machine. I will share with you now the process of doing milling and drilling. But first we have to differentiate between the milling and the drilling. The milling is the process of creating those traces. This is called milling, and there is a special head for the milling. Then after finishing the milling, which is to add or to fabricate those traces over the board, we need to add or to move to the drilling. The drilling is the process of adding drills or holes for each one of those pads here. So we need to add 1, 2, 3, 4 for all of those pads inside the board, and there is a special head for the drilling, and its size depends on your design, which means if you remember when we designed the pads, we said we have to categorize our tool size into categories. For example, we said for point 0.8 we give it category number 1. Let's say 1 millimeter, it's category number 2. 3 millimeters, it's category number 3. So the milling machine will start drilling the holes using the first tool you entered. Let's say it's 0.8 millimeter. Once the machine finished with or drilling the holes with 0.8 millimeters, the machine will stop and it will ask you to add the second tool size, which is 1 millimeter. So you have to add the 1 millimeter and then press start again. Then the machine will go and add the holes with, or it will fabricate the holes with 1 millimeter. Then after that it will stop and ask you to enter 3 millimeter. For 3 millimeters we have it only for the wire to board connector, so the machine will do only two holes, one here and one here. For point 0.8 it will do it, let's say, for here, and it will do it for resistors. For 1 millimeter, let's say it will do it for regulator and for the sensor, and so on. I will share with you now two videos, one for the milling and the drilling, and the other one it will show you the basic techniques of soldering over the printed circuit board. I will add the links here, so you will need just to go and open those links, and also you can find those links on your course Moodle page. So I will add the links now, and you have to run them. the other video showing you the basic techniques of soldering electronic components over a printed circuit board, as you will see here. Okay, so by this we finished our project. The last step it was the soldering. So once you finish the soldering, which means you are ready to test your project. If everything is working fine after connected to the source, then your board is ready to be used and this will be your final product. Uh, so just to remind you about the steps we went through this project, the first thing we did is to design or to do the schematic of the circuit of the project. After doing the schematic and simulating and doing the required hand calculation of the resistors and the required components, then we started designing the pads and footprints of the components. Then we connected them together with the traces over a board, and then we generated the Gerber files and drill files, and then I showed you how to do milling and drilling, and then the last step is to be soldering and testing of your project. So following these steps for each project we are going to design over using the printed circuit boards technology. So this is the thing that I want to show for today. Thank you very much.